Good morning, good afternoon. I hope you had a really nice coffee break, and welcome to the next round of talks. Welcome to the next talk. I'm personally very intrigued about the title because apparently blog posts do not tell you all the truth about Patroni. And our next speaker, Cameron Murdoch from University of Oslo, is going to tell you what the blog posts do not tell. Please welcome him with a round of applause.
Hello, hello. Yeah, thanks very much for coming. It's Friday. We've had a really good conference so far, and we're going to talk a bit about Patroni today, and then we're going to eat some lunch. My name's Cameron. I am originally from the UK, but I live and work in Oslo, doing database things for the university. And of course, what that really means is that I spend most of my time writing YAML files. Now, the title of the talk is What the Blog Posts Don't Tell You. And the idea here is that it's pretty easy to go online and find like a recipe for setting up Patroni, but that's not necessarily the same thing as having something production ready. So we're going to talk about, I'm not trying to say that I'm necessarily a Patroni expert, but that this is just some of the things that we encountered when we were setting this up some years ago. What are we not going to talk about? We're not going to talk about Kubernetes. We're going to pretend it doesn't exist. We're not going to talk about synchronous replication because I don't like headaches. We're not going to talk about any DCS other than etcd. What is a DCS? Don't worry, we'll come to that. And we're not really going to talk about Postgres either very much, funnily enough. We're kind of going to assume that everyone's got a good handle on how to get Postgres working. Okay, let's start. What is Patroni and why do we care? Well, Patroni's documentation says this, that it's a template for building high availability Postgres solutions. So Patroni is a Python program. It manages and runs Postgres for us. When we use Patroni, we don't run Postgres ourselves. We configure Patroni, and Patroni manages Postgres. And it uses Postgres' built-in streaming replication to set up and manage read-only replicas, including automatic failover to those replicas if that needs to happen. Now, why do we care about that? Well, computers are rubbish, they break all the time, and so we invented stuff to make them more reliable. But even with all this stuff, we can still have things going wrong. Linux can fail, Postgres can fail, storage can fail, networking can fail. Basically, the world is terrible. And I kind of get the feeling that people tend to think their data is quite important. So if we just have a quick kind of thought experiment, if you think about the most important database that you manage or are involved with, and somebody did this and stopped it, and it wasn't running anymore, how long would you have before people started screaming? If you raise your hands if it would be within a day. Yeah, what about 4 hours? Yeah, 1 hour? 30 minutes? 10 minutes? 5 minutes? 1 minute? 30 seconds? Yeah? Yeah, exactly. That's right. So one solution to this is you build a cluster, you run your database on many things, and then you can fail over between them if you need to. And Patroni essentially makes this easier to do, right? It does this for us. You can do it yourself, but I don't know why you'd want to do that anymore. Why might you not want to run Patroni? Well, we're going to play a little spot the difference game here. Here is a representation of a single node Postgres instance. It's just a single server with some database clients. And I want to see if you can spot the difference between a typical Patroni installation. Yeah, so this one's a lot more complicated, right? There's a lot more stuff. There's a lot more stuff to understand. There's a lot more stuff that can go wrong. And we're not just dealing with Postgres anymore. We've got other components in the system that we need to think about. So we're going to ignore the proxy layer, and we're just going to very quickly try and set this up, right? How you would if you were following a blog post. And to start off with, we're going to need a distributed configuration store. Now, what is that, and why do we care? Well, Patroni uses this to store some of its configuration data. There are certain bits of configuration that need to be the same on all of the nodes, all of the Patroni nodes. And things like etcd or the other things that Patroni supports are good at doing this. etcd is a distributed key value store, and it's really good at answering the question, what is this value, and making that consistent across a cluster. My opinionated first bit of advice here is that unless you have a reason to use something else, just use etcd. If you already have console running, use that. If you're running in Kubernetes, then you have other options. But if you're setting this up from scratch, etcd is probably the thing to use. So we need to set that up. But immediately, we have a decision to make. How big should our etcd cluster be? We're building a highly available system. etcd needs to be highly available. And etcd needs a majority of nodes running and accessible to work, right? And the way these things work is that if you lose quorum, your cluster stops working. So if you have a cluster size of 2 and one of your nodes goes down, that's it, it stops. By the way, I am going to put the slides up after the talk, so you don't need to take photos unless you really like taking photos. So what this essentially means is that we need to always have an odd number of etcd nodes. If we go from 3 to 4, we increase our quorum, but we don't increase our failure tolerance. And probably 3 or 5 is what most people are going to be using. And typically when you start up etcd, you see something like this. All right? Normally you see it as a command line, one long command line string with all these options. I've put it as a config file because I think it's a bit easier to read. And the reason people have it as a command line is because all the stuff that begins with initial is just for bootstrapping. Once you've done that and started it up and running, etcd doesn't care anymore. It's inside its own config, and you have to use runtime configuration to make changes. But if we run the above config on 3 nodes, it works. We get an etcd cluster. It's a key value store. You can put data in. You can get data out. Hooray, it works. So we can now use this with Patroni. Here's a typical Patroni installation file, where this is a lot of data to have on one slide. So if we look at it individually a little bit, we're essentially giving Patroni a cluster name, the scope, and we're also telling it where to find etcd, and then we're also giving Patroni some bootstrap information. This stuff gets written to the DCS, and then Patroni will use the DCS as its source of truth. So this is only used from the config file when you first start up Patroni. And then there's also some local config as well. And if you run the above config, this works too. And you get, here is a 3-node Patroni cluster. P02 is the primary, the leader, and you can run some SQL against that, and you're connected, and it's working. And we can do a quick failover test. Here I'm using target session attrs. If you don't know what that is, that's a connection string parameter that lets PSQL will connect to the first host it finds that is the primary from that list of hosts, which means we can write on this query even though we don't know who the primary is, right? And then someone does something stupid or something happens, P02, which is the primary, is dead. Patroni is supposed to fail over for us. Who's the new primary? We don't care. We can just connect again with the same thing, and that will work. It will insert the next that row. As it happens, P01, in this case, became the leader. And there's the SQL that shows that those rows were inserted. OK, I think that's it. We can take lunch early. We're finished. We've done it. No need to carry on. But let's just go back a moment to etcd and look at this. When you look at this, is there anything that you see that makes you go, ugh? Anything? OK, that's actually a good answer, but that's not a problem because isLearner is, it doesn't matter that these are not learners. That's if you're adding like a new member to the cluster. There's something else that I immediately look at this and it makes me a bit queasy. It's not encrypted. Everything's using HTTP. Incidentally, etcd listens to 2 endpoints. Peer is used for its own internal communication mechanism between the clusters. It's where the rafting protocol is implemented and where how etcd functions. And client is for incoming clients like Patroni to connect to etcd. So, it's actually worse than this. There's no authentication either. So anyone who has network access to etcd can do this. You can just write to the database. This D29YA thing, that's the base 64 string for the word works. And all this does, it might look a bit complicated, but all it's doing is just showing that you can read and write from etcd with no authentication, no encryption. Now, this might actually be okay, right? In some environments, you might not particularly care. But in some environments, it absolutely is going to matter. Because if we think about what's in the DCS, right, what are we storing in there? Patroni is storing this in the DCS, right? But this is just the starting point. You can put way more in there. You can put in pretty much any Postgres parameter, any PGHBA parameter, anything is in there. So my question is, would you give everybody on your network global write access to PostgreSQL or pthba.conf? The answer is you probably wouldn't, right? So we've got to fix this. This is how you enable TLS for etcd. We've put in HTTPS instead of HTTP. We've added some crypto. We've configured certificates. And one thing to note is that for the peer endpoint, we've enabled certificate authentication. And I really like doing this because what this essentially means is that the peer endpoints are now mutually authenticated, right? They're using those certificates both for server authentication and client authentication. And I quite like this because it means that the peer endpoints are now completely isolated. They're their own little thing. They're secure. Nothing else is ever going to connect to those. It's only etcd that needs to talk on the peer endpoints. And I think this is potentially a good use case for internal certificate authority. You can set that up and you know it's safe and nothing's going to affect it. And if we run the above config for a new cluster, you get this, and now everything has got an S on the end. We're all happy. You can add TLS to an existing cluster. It's a little bit more work, but there is documentation on how to do that. So TLS is done. Let's enable authentication. To do that in etcd, we need to use its role-based access control system. We have to add a super role called root. We then add a super user, also called root. Then we grant root to root, which is always fun. And then we can enable authentication. And now if we try to do something, etcd complains we haven't given it a username, and you have to give both the username and the password, and you can then connect again. But now the question is, we need a user for Patroni to use. We could just use the root user that we just created. But, I mean, we don't give out super user access to Postgres, right? Do we? No, hopefully not. So a better idea would be to create a user in etcd for Patroni, for all of the clusters you've got. But I think an even better idea is to create a user per Patroni cluster. The idea here is that if you've got, say, cluster A and cluster B, you don't want cluster B to have access to cluster A's config, right? There is a security issue there. It could be compromised and it could affect other clusters. But there's also just, misconfiguration. If you accidentally set up cluster B to use cluster A's name, it could take the wrong config, and I don't think we want that. So let's fix that. We need to add another role. We need to grant some permissions to that role. And what this is doing is this is saying, so /service/pg fixed, this is going to be the key space that Patroni is going to use in etcd. The default in Patroni is to use /service/pg service/scope. Scope is just the name of the cluster, right? And it will use the key space below that to store its config. If we do that, we then have to create a user, and then we have to grant the role to the user, and we now have an etcd user that can read and write to the key space under service pg fixed, right? So we can now configure Patroni to use this. We've fixed two things here. We've now got protocol HTTPS. So Patroni is now going to use HTTPS to connect to etcd. And we've also given a username and a password. If we run this, it should work, but Patroni's REST API also has no encryption or authentication based on the config we used. Anybody can do this. You can just post to an endpoint and cause a switchover. You could also do this. So the config that we just locked down in etcd is fully open through Patroni's REST API. We can just patch into the config, and we've just overwritten pghpa.conf. And the way this will work, Patroni is very helpful. It will push this out to all the nodes and reload them automatically within, by default, 10 seconds. I'm going to say this probably isn't a good idea. So we need to fix this, and this is how you do it. You would configure Patroni's REST API to have a username and a password, and to use TLS. You can set some security headers there. There are other headers you can set, other security features you can put in that you might want to look at in the documentation. And now if we try to do the same thing we did before, we'll get an error that says we can't do it because we're not authenticated. That was HTTP basic auth. And that's probably the minimum that you're going to want, I would suggest. You can also use certificates for authentication here, and that is what we do. And I think that's probably better. So this is using certificates to authenticate against Patroni's REST API. And I think there are some benefits for that, because otherwise you've only really got one user here. Whereas with certificates, you can kind of have different ones and invalidate them and have different setups. You should also look at allow list and allow list include members in the documentation. These are ways of restricting who has access to Patroni's REST API. Right, some other things to mention. DCS, other Patroni config that isn't standard that we should talk about. DCS failsafe mode. Now you almost certainly want this on. This increases the robustness of Patroni in the event of a DCS outage if ECC is down. Now, why might etcd be down? It could be because there's a network partition, right? And it can't talk to each other. It could also be that etcd is just crashed on all the nodes. Patroni can't tell the difference. It doesn't know whether there's half of the cluster is on the other side of a network partition, or whether it's just that etcd itself is temporarily down. And so because of that, the standard is that the default is that if Patroni can't talk to the DCS for any reason, it will demote the primary. And this is a little bit unhelpful if the only problem is that etcd is just temporarily down for a few minutes, right? So if you turn failsafe mode on, then as long as Patroni rather, can talk to all of the other nodes in its own cluster, and they're all okay, then nothing will happen. Everything will still work. You won't actually have any downtime, and you can then fix etcd and get it back up and running again. How do we turn that on? When you're bootstrapping the cluster, you can put failsafe mode true, or you can do it on a working cluster with Patroni control. And I don't really see a reason why you shouldn't have that on. The next thing to think about is Patroni has 3 places where you can put config. what it calls the global dynamic config, which is the stuff that goes into the DCS, local config, which goes in the config file, and environment variables. There are a few things that have to go in the DCS, and if you try and put these elsewhere, Patroni will ignore them. And that's because these all have to be the same on all of the Postgres nodes. But where should other config go? Should it go in the DCS or should it go local? And the answer is it kind of depends. Dynamic config is applied to all nodes and is pushed out automatically. And this can be good. This is a dynamic application of Postgres config. If you need to change workmem to a new value, you can just change it in the DCS or via Patroni control, or you can do it programmatically, and it will automatically get applied, and all your nodes will be reloaded without you having to do anything. And that's really handy. At the community day on Tuesday, the Patroni community segment, somebody semi-joked that people are running Patroni with single-node Postgres instances just because it makes applying config easier. I actually don't know whether that was a joke or not. But this could be a problem if you're applying config to a node that you didn't actually want it to get. When we set up our stuff some years ago, we were already using Ansible to configure PostgreSQL.conf and HBA.conf already, and it was kind of natural for us to just use that existing infrastructure to update Patroni.yaml rather than work with the DCS. But if I were to set everything up again from scratch now, I would probably put more stuff in the DCS. And I think that is something that we will start to do over time. Other things to mention: don't run etcd and Patroni on the same nodes. You often see this in demonstrations, that it's just done to make the demo easy. It's bad because Postgres can eat all the resources and then etcd won't work, which means your cluster won't work. It's also, I think, easy to make mistakes. You could decide you want a 2-node cluster, but we don't want a 2-node cluster with etcd. And if you go from 3 to 4, you might accidentally add a 4th etcd node, and you don't want to do that either. And the other thing is there's absolutely no problem running several Patroni clusters from one etcd cluster. You can run quite a lot. You might choose to split them up for business reasons, but there's nothing preventing you from running lots against one etcd cluster. And this is what we do. We have a few etcd clusters, but we have several Patroni instances running against the same cluster, and it works very well. I cut out the section I had on proxies, unfortunately, because I didn't think there was time. But one thing I will say is maybe you don't need a proxy, or at least you don't need a proxy for everything. The reason we would have a proxy is that clients connecting in don't know necessarily the host names or the names of the Postgres nodes, the Patroni nodes, and so it's a way of hiding that away from the clients, and also the proxy controls automatically rerouting the traffic onto the new primary in case of a failover. But you can also just do this with libpq, with the thing we've been doing so far, where you put in a list of hosts and target session attrs. You may want to reduce connection timeout if you do this. I think you can set that to lower than 2 these days. And that just means that if P01 is down for some reason, it won't wait for a timeout before it connects to the next host in the list. And from PG16 onwards, you can load balance this connection as well. What that will do is it will randomize the host order and then connect to the first standby it finds. But if it can't find a standby, it will connect to the primary. So some things can use this, right? You don't have to go through the proxy necessarily. And you can have a system where maybe your main application is going through a proxy, and other things can connect straight to the database, to Patroni and Postgres. Everyone loves backups. Even though etcd doesn't contain real data, I think you probably do want to backup. It's not that difficult to do. It's just this snapshot command. And I think this could help in a disaster recovery situation, especially if you do have lots of Patroni nodes running off the same etcd cluster, recovering in the event of ECDC failure. This is going to make your life a little bit nicer. Postgres backups. You can run that through the proxy if you have one. But this also seems like something that you could just do direct. If you know, seeing as we're setting this system up, we know what all the hosts are if you're in an environment that isn't too dynamic. And so pgdump will work just fine with the same settings we had before, where you have a list of hosts and you set target session attrs to primary. You can also take the backup from the secondary. That will also work. You do sometimes need to be careful that that query, the pgdump query, doesn't get cancelled if you have a lot of changes happening on your primary. But it can work, and we do that sometimes. If you're using point-in-time recovery solutions like Barman or PG Backrest, that will also work. You can do this. Barman uses we use Barman, and you can have two strings, one for normal connections to the database to do PG-based backup and check settings and stuff, and one for streaming the walls. And this works. On failover, Barman will reconnect to the new primary and start taking walls on the new timeline. You can also take backups from a replica. And you can also use Barman as a Patroni bootstrap method to bootstrap new replicas or new clusters. And we had a talk about that earlier in the week, using PG Backrest to do that. And that is a good thing to set up, because what we need to think about when it comes to Patroni is new timelines will be created, right? So you need to have a solution that can actually recover to earlier timelines. Now, what is a timeline? If you're only ever used to using single node Postgres, you may not have had to deal with timelines. But if you're using Patroni, you will definitely find that you get timelines, and you may not always want to recover to the latest one. So whatever backup solution you're using, you need to test that you can actually get to other timelines if that is something that suddenly becomes important. And of course, we should be testing full disaster recovery, right? If I ran rf star on all of your things, can you recover? How quickly can you get that back up? And this is where having Barman or PG Backrest set up as a bootstrap method could be really useful, because then you can bootstrap a new cluster up fairly quickly using that system. So that does mean we need to be setting up test clusters and doing test restores as if the main thing had gone, right? Talk quickly about upgrades. We need to upgrade etcd. This can be done on a running cluster without downtime. It's very nice. You pretty much just stop etcd, install the new binary, and start up again. But you should read the release notes for each new version, because sometimes there are little hoops you might have to jump through. And you must upgrade one node at a time. Because if you've got a 3-node cluster and you do 2 at once, you've just lost quorum, and your life is unhappy. We have Ansible automation that does this, that will connect to the cluster, check that it's healthy, upgrade one etcd node, check that the cluster's still healthy, do the next one, check it's still healthy, and so on. And that's the sort of approach I think is good, because this is the sort of thing that can be error-prone, can be easy to get it wrong. And our etcd clusters, the individual nodes have all been upgraded and restarted several times over the last 3 or 4 years. But I don't think the cluster as a whole has ever had downtime in that period. So it's pretty good, like it works well. Postgres upgrades. Postgres minor upgrades. They're a little bit more work than normal, but actually I almost think that Patroni helps the user experience here, because you can upgrade each replica as you normally would, one at a time. Then you can do a controlled switch over to one of them, and then you can upgrade the old primary. And this can kind of be automated as well, or semi-automated. And what's nice about this is, I mean, okay, we're taking an already fairly quick process and making it quicker, but we are reducing downtime here, because instead of the time it takes to shut down Postgres, install the binaries, and start it up again, we're now just doing a switchover. That's the only downtime that the end user sees. And I think any time we can reduce the pain of upgrades is worth it, because then we can upgrade more often. And certainly for minor upgrades, I think that's a good thing, because we should generally always be applying Postgres minor upgrades. Major upgrades are a different story. They're a bit painful. It's difficult to do without some downtime. You could just set up a new cluster and do pgdump and pgrestore for each database into the new cluster. This might not actually be a terrible idea if your databases are small, or if your highly available cluster only needs to be highly available at certain times. If you have a window where you can do this, the complexity is relatively low. Yeah, you have to set up a new cluster, but the actual process is well understood. And it also means you can move a database one at a time rather than migrating the whole cluster, right? Another option, which is the mechanism described in the Patroni documentation. You can use PG upgrade on the primary. If you use the right options to PG upgrade, then the downtime for the primary is lower. But by default, you'd have to reclone your replicas from the new primary, and that could take some time. So your replica downtime might be high. Depending on your business case, your use case for this, that might not be acceptable, because you might not have high availability until your first replica is back up. Another option is to use link with PG upgrade and then rsync. So link sets up hard links between the new PG data and the old PG data. And you can rsync the hard links across to the replicas, and this reduces the downtime for the replicas, how long it takes to get your replicas back up and running. And this, I know that some Patroni developers are looking at making this an option with Patroni, at like automating upgrades, major upgrades, using this mechanism. So this might be the way that we end up going for things in the future. And another option would be to set up a new cluster and try and use logical replication to migrate across. This is by far the most complex option, but has by far the lowest downtime. You can get your new cluster up very quickly. All you have to do is just move once you've decided to promote your new cluster, you just have to reroute your traffic via your proxy. But it is probably, we've had talks on this before, of doing logical replication to do major upgrades. It definitely can be done, but there's a lot of edge cases and situations where you need to cover and test, and it's definitely not something to be taken on unless you really need that level of high availability. And I have actually finished earlier than expected. So we have a lot of time for questions, if there are any.
Amazing, thank you.
Regarding logical upgrades, is there anything Patroni, is that like the most, would you say that's the most complex just in and of itself, logical, as someone who's done logical upgrades, I understand that. Is there anything that's like Patroni specific, as someone who doesn't use Patroni right now but is thinking of adopting it, is there anything Patroni adds on top of that complicates things further, or that's important to keep in mind?
I don't think it complicates it necessarily. Patroni will, you can have Patroni track your logical replication slots for you, and they will fail over between the primary and the replicas and stuff. And you can use Patroni to set up a standby cluster. That would be running on the same version, but you could use that as a way of initializing your cluster that you're then gonna. You could do that, run PG upgrade on that, and then establish logical replication. So actually, Patroni might help get it up and going.
Thank you very much for useful talk. I had two questions. First, is libpq's multiple host functionality works on application side? For example, on JDBC support set or not?
I don't know about JDBC. Anything that supports libpq will work with that. Yeah, JDBC does it as well. Yeah.
Okay, great. Second question, from your experience, for example, if we have multiple Patroni clusters with different Postgres versions, let's say 14, 15, 16, can we use a centralized etcd cluster for all of them?
Yes.
Okay, great, thank you.
Very short answer. That's exactly what we do. We have different versions. That's all fine.
Hi. Could you please shed some light on how you upgrading Patroni itself? And
what we have done is when we do minor Postgres upgrades, we tend to upgrade Patroni at the same time. We do read Patroni's release notes quite carefully, and we test it first. But because when you do a Postgres minor upgrade, what's the procedure there? You stop Postgres, which in this case actually means stopping Patroni, right? And then you upgrade your packages using whatever package manager you have, and then you start Patroni back up again. So it seemed like a fairly natural place to do it. If you've got a really big difference between the two Patroni versions, you would want to definitely check that nothing's changed that could, break anything. But my experience has been that that very rarely happens. So that's just how we've done it.
Hi, Cameron. Thank you for your talk. Really good. Really loved the content and the way you presented it. I know you didn't talk about etcd and Patroni in the context of Kubernetes, but I'll just add that if I had customers, we use Patroni on our operator, our Kubernetes operator, and for the people who are running Patroni and within a Kubernetes environment, one mistake that I've seen over and over is that people forget that etcd is answering for all of the configuration of all of the Kubernetes nodes, including Patroni.
Yeah.
So when they use an undersized etcd, they undersized the resources for etcd, it impacted Patroni and brought their whole cluster down. So make sure that you give enough resources for etcd. So I just wanted to add that for people.
That's actually a good point. etcd isn't always so demanding for like CPU and stuff, but it's very picky about how fast the disks are and how fast the networking is. We had a thing, we run on VMware, and we had a thing about a year or so ago where our etcd went mental. Everything ran fine, but we had this, all these errors coming in our monitoring system saying that it was having trouble persisting to disk. And I contacted the storage guys and said, we measured this millisecond difference. And they were like, oh yeah, we had a problem. No one else noticed in the entire university. The only thing that squeaked was etcd. So it is quite sensitive to that.
Thanks for the talk. A question on this first step on securing etcd. So there was this password, in the config file. So does Patroni already have some native way, let's say, to read stuff? I know that it supports n variables, but is there something else, in the style of Ansible vault strings or some files to, look up the password so that, one could just commit the stuff?
You mean this thing here, where you're using a password to connect to etcd?
Yeah.
Yeah. So I use certificates for this. Actually, I don't use. Oh no, I don't. Sorry, you can't use that with etcd3. No, I haven't found anything to make that better. No. That's the point with etcd without the 3. I think you could use certificate authentication, but with the newer versions of etcd, they've disabled version 3 API. So because of the way that's implemented using a gRPC proxy and stuff, it doesn't work with certificate authentication, which is annoying.
Again, thank you for the talk. Word of warning on etcd running on VMware. Tell your infrastructure guys to put them on different machines.
Oh, that is actually something I should have put in the talk. We do that.
Great.
We have, and that's actually not just etcd. You should do that for all the groups of nodes. So all the etcd stuff needs to have an anti-infinity rule, right, to make sure it doesn't run on the same physical machines, and the same for all the Patroni nodes.
Of course. Yes.
Yeah.
But my question is on virtual IPs or overloaded DNS records to find the primary. Have you ever played around with that to try and reduce time? Because that way you don't have your connect time out, that you have to go down and search the nodes to find the primary.
Yeah. So although we do this, what I just showed for backups and stuff, where maybe a slight delay in connecting doesn't really matter. For all the production stuff, it is going through HAProxy with a virtual IP, and that works very, very well. And then, yeah, it's just a single address that the clients connect to. One pain point there, and I should have put it in actually because we did have time, is if you've just set up one virtual IP with one HAProxy cluster, it then becomes a little bit tricky to upgrade HAProxy on that, because to upgrade it, you have to restart it, which means there's going to be a failover of HAProxy. And if you use a sort of default HAProxy config, you'll actually get two failovers, because it will fail over to the backup, and then it will fail back to the primary when it comes back up again. So I am thinking that it might be sensible to have, like you say, overloaded DNS, where you have multiple HAProxy clusters, and you can take them in and out of the DNS as you see fit. But if you do that, you'll still get a timeout.
Yeah, and the DNS, it'll still do the search.
Yeah. Yeah, well, Postgres, if it's libpq, for example, it will still, if you get a host record that resolves to multiple IP addresses, libpq will still try each address in turn, and will still time out if that address doesn't answer.
Yeah, we mostly use the overloaded DNSs for standbys and things like that.
Right,
For the primary, we have one virtual IP.
Yeah, cool.
Connect timeout is really important. So,
yeah.
Okay, thanks.
Hello, thank you for that excellent talk. I'd like to ask you how to properly rotate the certificates on etcd as well on Patroni, just when the certificate is about to expire, to keep all the things up and running.
Yeah, it's a good question. So I talked about using certificates for the peer endpoint. If you really didn't like renewing certificates, then for the peer endpoint, you maybe could just create one yourself that had a very long lifetime. I think that might be acceptable. But we don't do that. We do renew stuff. We have implemented quite strict monitoring, that we get alarms for things if they're about to expire. What we've also done is tried to offset when certificates have to be renewed for each node in the cluster, so you're only doing one at a time. But in practice, and what's good about etcd is you don't have to reload anything. You just push the certificate, and it automatically starts using it, which is quite handy. And actually, we're going to automate that even more soon, so that it's pretty much, we never have to do anything.
Hello, colleague. My question is rather simple, but when you bootstrap and you have the etcd in the bootstrap init section, right? What happens if you break etcd, or like you delete everything inside etcd? Because you said we should take backup of etcd. Do you have to re-init etcd again, like kill the cluster of etcd and take it up again, or like bring it up again from scratch?
This. Yeah, I mean, yeah, if you bootstrap it and it doesn't work, then is that the question?
one of the issues that you could, you said that you could break etcd by deleting everything of the content, right?
Oh, I see, yes. Yeah, yeah, so you had to have a choice. You could re-init from scratch,
Right.
but you could also restore from backup if you
Right.
have a backup. And
Because
if you
then-
had a lot of data in etcd, then restoring from the snapshot would be...
Because
would be
if you have done a lot of dynamic changes in
Yeah.
CS.
yeah. Yeah, so that's another option. You can... Yeah. Yeah, Patroni also has the data in a file, so you can restore it that way too. But my thinking is if you have a lot of Patroni clusters, you don't want to necessarily to run it for every cluster. Okay, it does it automatically. You don't have to do anything.
Hey, if you could go a bit more into your use case of how you, because you said you run Patroni out of one or some amount of etcd nodes.
Yes.
You said. So do you just leverage the DCS URL argument in PatroniCTL in
Yes.
order to push?
Yes, so you would here, for another cluster, another Patroni cluster, you'd have the same host list, but your scope would have to be different. Yeah.
Okay, so you also keep the YAML files, or several YAML files within that same node, correct?
Yeah, so if you've got two Patroni clusters, cluster A is going to have mostly the same config. The only thing that's really different is the name. Each node gets its own name. And then another cluster, the config is also likely to be quite similar, but you'd have to have a unique scope.
No, I understand that. It's
Yeah.
more. My question was more of whether or not you relied on the DCS URL and you just used that as an entry point per se from where to run PatroniCTL on, or whether or not you had all of the config files, regardless of
Yeah, I see.
how similar or not they are in the same machine. That was it. Cheers.
Yeah, the files.
Yeah, one question. After major version upgrade, the system ID of the Postgres changes. So is there a way that system ID can be updated in HCD?
Yeah, so that's what this, where is it? Right at the end. That's where this major update thing is. The procedure is that you blank the DCS, or at least you remove the system ID from the DCS, and then you use the fact that Patroni will re-add that data afterwards. So you do the major upgrade. Part of the major upgrade is that you have to remove something from etcd as part of it.
Hi. Are you setting non-default parameters for etcd?
Not particularly. I don't think so. There's a few things that I didn't put in, like compaction. You need to make sure that you defrag and compact your etdc key space, because etcd by default keeps revisions for everything. And eventually that will just grow and grow and grow. So you need to make sure you're compacting the database regularly. But
what kind of tool you monitoring the etcd metrics?
Monitoring, the university already has Zabbix running on Postgres, so we help run it. And we've set up Zabbix monitoring for Postgres, Patroni, HAProxy, and etcd. And then we can extract that into Grafana as well.
Okay, thank you.
Any more questions? We probably have time for one. No? All right. Then thank you very much. And there's a round of applause for our speaker.